Alright, ladies and gentlemen, today we're essentially going to be doing a review of exactly what we did on Friday. I imagine that some of you had a challenging time putting all these pieces together, and so today we're going to look at it again and a few more challenging problems, but the concepts are exactly the same. So what we're going to be doing is graphing these quadratics, but instead of using that messy t-chart, we're going to use factoring because we know factoring can give us the roots. And so let's review what we're going to be doing here. Alright, so remember what we really care about when we graph it is we need to know where it hits the ground and how high or how low does it go before it turns. We need to know the turning points, we need to know the intercepts, and then we can eyeball the rest, right? So if I ask you for the solutions, if I ask you to solve a quadratic, remember those are the roots, the x-intercepts, the zeros, because that's where ground zero is. We need to know where it hits the ground. And recall, if we know where it hits the ground and we know the line of symmetry is exactly in the middle, then we can find the vertex and we have our 3 points. We don't need a t-chart, just 3 little points. So we're going to start here with a graph of 25x squared minus 4. Alright, so the first thing we need to do is figure out where the x-intercepts are. Where does this hit the ground? In order to do that, we need to make the ground 0. So we're going to change this y into 0 because we know the y coordinates for those points is 0. Then we're going to factor this equation and we will have 2 binomials. We will set each binomial equal to 0 to solve for x to figure out what number on the number line on x does my graph hit the ground. So here we go. Alright, so we're going to take a look at this and we go, alright, I have a leading coefficient here and I'm really not sure what to do. But I notice that this is a perfect square. I notice that this is a perfect square. Wait a minute, I know that pattern. So if we're going to factor this, we set it equal to 0 and we say 5x times 5x is our 25x squared. Negative 2 times positive 2 gives me my negative 4, and if I check this, negative 10x and positive 10x cancels out. So I get what I started, and there's my factors. But again, I have these leading coefficients. I can't just put in the opposite here. We need to actually set each of these pieces equal to 0. So we're going to say 5x minus 2 equals 0, and 5x plus 2 equals 0. Each of these is going to be a separate point. Then we solve like we usually do, and yes, we're going to get a decimal, and that's okay. We have our calculators. We're going to have positive 2.5 and negative 2.5. So now let's go over to our graph, and now we know where it hits the ground. So, right, these are my solutions. Those are the points I'm putting on my graph. So coming over here, we're going to put negative 2.5 and positive 2.5 on the graph. Alright, with those points now, we can find our line of symmetry because we know it's the same up as it is down. We know it's going to be exactly in between, and so I'm going to come in 1, 2.5, 1, 2.5. Oh, my line of symmetry is right down the middle of the y-axis. Beautiful. So that means my line of symmetry is x equals 0. Right? X equals 0. That point right there crosses right through 0. Now the last thing we need to do is find the vertex. Now let's take a look at our equation up here. We know that our equation is going to open up. We know the y-intercept is going to be negative 4. And we know that the vertex is somewhere on this line. Since it opens up, we know our vertex is going to be somewhere down here, so it opens up. So all we got to do is take this x over here, which was 0, plug it back in this equation everywhere where there's an x, and we can find our vertex. So we substitute that 0 in there. 0 squared is 0. 25 times 0 is, well, still 0. And 0 minus 4 is minus 4. So now we can plot that down there. That makes sense, right? Because we know that this is going to open up. So our vertex had to be down there. Those are the 3 points that we need. Oh, wait a minute. We have our y-intercept here, which is also our vertex. So that's all we got. And we're just going to eyeball our graph. Bink! There we go. That's all we need to do. Okay? So we factor, we find the line of symmetry from our factors, and then we can find our vertex by substituting in. All right, Now let's look at the next one. It's a little more complicated. This one has a leading coefficient again, and it's not a perfect square. So that means we're going to have to pay attention to our factoring here. So I'm going to give you a second here to factor this. So remember, you're looking for two binomial factors. In the first position, they multiply together to get 2x squared. In the last position, they multiply together to get 5. And the middle term should add together to get negative 11x. You're either using your guess and check, or you're using your Xbox method. So we're going to pause here to give you a chance to figure out the factors and go. All right, coming back, let's double check what we did here. We set it equal to 0, and when we did our factoring, we had 2x times x giving us 2x squared. Negative 1 times negative 5 gives us a positive 5, and negative 1x and negative 10x do give us our negative 11x. So these are the factors we should have. Now at this point, we're going to set each factor equal to 0. There's going to be two different points, and we need to know what value of x do we need to get 0. So we set each piece equal to 0 and solve. So we'll pause here again, figure out what numbers you're going to plot on the x-axis, which are your roots. All right, coming back, we should have factored, and we should have had x equal to positive 1/2 and x equals to positive 5. You don't have to have a positive and a negative root, just two different numbers. So those are our solutions. Those are our x-intercepts. And so if we go over to our graph, those are the numbers we're going to put on the x-axis. So here's our graph, and we're going to plot positive 5, and we're going to eyeball positive 1/2. All right, now from those points, we can find our line of symmetry. And you're like, yeah, but Mrs. Woolley, that's a fraction, and I'm not really sure how to follow that in. So you have two options here. You can either count in by spaces until you find what's in the middle. And if that's difficult, then we're going to use our line of symmetry equation, which is x equals negative b over 2a. And recall that the negative is part of the equation, so it's negative whatever b is. So in this case, that's going to be negative 11, which would give us our positive 11 over 4. And you're like, I don't know what that is either. So we use our calculator, and we get 2 3/4. Now we're just going to eyeball that on our graph. It's a good thing we used the line of symmetry, because I don't know if I would have gotten that otherwise. So we're going to go over to our graph, and we're going to eyeball 2 3/4. There's 1, there's 2 3/4, somewhere right in there. Bink, there it is. All right, let's go back up to our graph. This is positive, so we know the graph is going to open up. That means we know our vertex is somewhere down here. Now, yes, our x value is a decimal, but we have a calculator. So we're going to substitute this value for x into the equation everywhere there's an x, so we can find our vertex. So we substitute it in, and we're going to use our order of operations. We know that we have to do our exponents first. So we're going to do 2.75 squared in our calculator, then we're going to multiply it by 2, and we're going to write down that number. We're going to multiply 11 and 2.75 together, and we're going to write down that number. Then we're going to go this number minus this number plus 5. I'm going to give you a minute to do that on your own. All right, coming back, let's double check it. You should have had 15.125 minus 30.25, and yep, we're going to write out all the numbers, don't round. And then we're going to subtract them and add 5, and we get negative 10.125. All right, we're going to eyeball where this is, because we're just doing a sketch. And this makes sense because it was a negative number. We did say it had to be down here. It's just slightly off our graph. So we're going to put it slightly below. Oops, in my PowerPoint, I've run out of room. You can't see that dot. So you're going to put it just below the graph there, and then we're going to eyeball it up, and there we go. Now, we do know the y-intercept is 5, so if we continue this up, it should be crossing right here. I had a little difficulty with my PowerPoint program getting this parabola to look just right. But if you want your freebie point, it's going to come right up here and cross at positive 5. And then we come over here, and it's going to cross over here as well, equally spaced on the other side. So that's kind of our freebie point. The 3 points we have to have are our roots, and we have to have our y-intercept, which just got off my PowerPoint here. Sorry about that. All right, flipping it over, we have one more to do. All right, now this one is a little tricky. We take a look at this and we say, oh, we have a leading coefficient again, and it's also negative. And hey, that's a perfect square, but wait, that's not a perfect square. And this is set up a little different. Let's take a look at this. Yeah, you know, first thing we got to do is factor out the GCF of -1. We know it's going down. We're acknowledging it goes down, but we need to get rid of this negative so we can factor. We've never had negatives in front, and we don't know how to factor with a negative. So we're going to get rid of this. But we also notice these both can be divided by 2. So remember, you always factor out a GCF first before you do any X box or guess and check. So we're going to factor out this negative and a 2 first. So, and an x. They both have an x. Holy cow. So we're going to factor out a negative 2x. And when we do that, we have negative 2x, parentheses, 2x plus 1. There's no more squared, ladies and gentlemen. There's no x box. There's no guess and check. This is just a GCF. So pay attention. If there's an x squared and an x and no loner number, this is a GCF problem, not a guess and check. All right, and now I have 2 parentheses, and you're like, well, or two factors, and it's true. This is a parentheses here, but remember, it's being multiplied by this. So imagine this is also in parentheses. So we're going to set these 2 pieces equal to 0, so we can find out where they hit the ground. So we'll have negative 2x is equal to 0. Think of it like your parentheses. 2x plus 1 is equal to 0. And when you solve this, dividing both sides by -2, well, anything divided by 0 is 0. That's kind of a cool thing, your GCF. And setting this equal to 0, we will get -1/2. If you haven't written this down, we'll pause here to give you a chance to copy that down so you know this strategy. All right, so now we're going to go back over to our graph. There are my solutions. I'm going to put my roots at 0 and -1/2. This is going to be a tiny graph. So we go 0 and -1/2, bink. Wow, that's super close. Now let's look at this equation up here. We have this negative sign, so we know it's going to open down. So that means my vertex is going to be somewhere up here. And it's a -4, so we know this is going to be a really skinny graph. There is no loner number, so it's going to cross at 0. Oh, we can see that it does. All right, so all I got to do is figure out what is in between -1/2 and 0. Well, I can eyeball this, or I could use my line of symmetry. So let me see. If I use my line of symmetry, that'd be negative b, -2, over 2 times a, -4. I'm going to get -1/4. Okay, so whether you used the line of symmetry equation or you eyeballed it, in between 0 and -1/2 is -1/4, and we're going to eyeball that line in there, bink, and there it is. All right, -1/4 in your calculator is -0.25. And yes, it's a decimal. Most things in real life are. It's a good thing we have our calculator. So now we're going to go back to our equation, and we're going to substitute in -0.25 everywhere there's an x, right? And now, order of operations, we're going to do our exponents first, and then multiply by 4, write down that number. Multiply -2 times -0.25, and write down that number, and then we're going to combine them. We're going to pause here to make sure you can do this in your calculator. Go. All right, coming back, let's double check. All right, if you square this first and then multiply by 4, you get, wait a minute, why is there a negative, Mrs. Woolley? A negative times a negative is a positive. Nope, nope. Order of operations, -0.25 times -0.25 is positive number. Then you multiply it by the -4, you get a -0.25. Please use your parentheses when you're using your calculators to make sure you get your signs correct. Then you're going to add this. This one is a negative times a negative, so plus 0.5. When we add those, we will get positive 0.25. All right, that makes sense if we go back to our graph, because we knew that our vertex had to be up here. 0.25 isn't very too far up, so we'll eyeball that. Bink, There it is. And we knew this was going to be a long, skinny graph, and we knew it opened down, and that's what it's going to look like. Remember, we just need those 3 points, the roots, the vertex, everything else we just eyeball. All right, ladies and gentlemen, that is it for the notes. You are going to be handed out another graphing paper. It's going to be a review. Some of them will be easy ones like yesterday that don't have any leading coefficients. We just factor and set their pieces equal to 0. Some of them will be negative, so we need to factor out that negative sign first. And some of them will have leading coefficients, which means that your roots might be a decimal. So you'll be given the rest of the time in class to work at your own desk and get your work done. Mrs. Thomas will be there to help you, but you must be in your desk and working. You may not be roaming around, you may not move over to hang out with your friends, but you're at your own desk working, making sure you understand this, because if you pay attention to School Loop, you will see that you have a quiz on this tomorrow. You will be given 4 graphs, and you will be asked to graph the quadratic equation. So you want to make sure you're taking advantage of this time to make sure you understand it. Be good for the sub, and I will see you tomorrow.